In this session, we will discuss how to construct frequency distributions or histograms using Excel or Microsoft Excel spreadsheet. Hopefully, we'll have time to talk about some of the applications and some of the information obtained from the frequency distributions or the cumulative frequency distributions. But the key topic of this session would be to illustrate and demonstrate how we construct histograms and the cumulative frequency curves on Excel. Let us start going to the slides and see how we can actually do that. I will first go over some slides that describe the steps of constructing a histogram, and then we will go to Excel spreadsheet and actually perform the analysis step by step. Let's take this example, students' grades. And students' grades is a common example that I use because it's easy to use for students. And it's one of those that are identified as larger the better pattern. As we all know, the larger the students' grades, the better for the students for sure. So here is a set of students' grades. This is 40 observations. And in Excel, given that we have already data and data analysis, the first step to construct frequency distribution is to first perform descriptive statistics. So using the data set, and as you can see, we need to arrange it in one column. We need to construct descriptive statistics first, and that gives us a good idea about the minimum value and the maximum value, so that we can, as we discussed earlier, get a good idea about the range of the histogram and the span or the expansion of the histogram, and also to be able to create or determine the most important factor of histograms, which is the class width. So first we do descriptive statistics, and then we create a column that we call bin range. If you notice here, this column starts at a value of 45 and it goes all the way to a value of 100. As I said earlier, we start at a value lower than the minimum, which is 48, and we end up at a value higher than the maximum, which is 98. So we have 45 to begin with, going all the way to 100. And in between, we have the class width, 45 to 50, 50 to 55, 55 to 60, meaning that we have decided on 5 points grade as our class width. This is, as we said earlier, is a very important decision that we have to make before we move on with constructing a histogram. So we create a bin range, and we are almost ready now to go to Excel and go to data analysis so that we can construct a histogram. Now we go to data, then data analysis, and in the data analysis menu, you will see a histogram as one of the sub-menus of this tools. So you go to histogram, and when you go to histogram, you will be prompted to another menu. So data, data analysis, histogram, and then you will see this menu here where the first window is asking you to put the input range, which is basically the grade values, the entire column of grade values. And the second window is asking you to input the bin range. Remember, we have prepared the bin range in advance. And after that, you specify a point in the spreadsheet where you can put your output, and then you click OK. Before you do that, you need to select cumulative percentage and the chart outputs. Chart outputs is going to give you the histogram, and the cumulative percentage will give you the cumulative frequency distribution. The steps, as you can see here, are very simple, and the output you're going to get will look something like that. We have a histogram, and we have a cumulative frequency curve superimposed on that histogram. Let us now go to Excel and go over these steps step by step. Here we have in Excel the students' grades. And as you can see, students' grades were presented in 2 columns, as you can see here. And what we need to do first is to arrange all the values or all the observations in only 1 column. So all grades will have to be in 1 column all the way to the 40 observation. That's very important because Excel, like any other softwares, will only deal with 1 column or 1 row format. As we said, the first step is to perform descriptive statistics so that we can have a good idea about the span or the range, the minimum and the maximum of the data. So we go to data and we go to data analysis as we did before, and we select descriptive statistics. And at descriptive statistics, we will be prompted to another menu where we have to insert the input range, which is starting at cell 2, column M, all the way down to cell 42, column N, including the labels, which means we have to check this box here, which indicates that we have labels in the first row. The default arrangement is columns, so we don't have to do anything about that. And we have to select summary statistics as we did before, because we are about to get our summary statistics. Then we select an area in the spreadsheet, which is the output range. As you can see, when you click on output, it jumps to the input. You want to anchor it again and click here again, and click a point or a cell in the spreadsheet where you don't have anything to the right or the bottom, so you have enough space to produce or display the output. And then we click OK, and when we do that, we will get the descriptive statistics of the grade data. Let me just enlarge this a little bit so we can all see it. We have the mean value, we have the median and the mode, and we have the standard deviation, the variance, as we did before. But our interest this time, since we are planning to construct a histogram, would be the minimum and the maximum values. And as we can see here, the minimum for this set of grades is 48 and the maximum is 98. That helps us in creating the bin range that we mentioned earlier. So now I'm going to type bin range, and I'm going to prepare a bin range column. And as I said earlier, we start at a value that's lower than the minimum. Well, the minimum is 48, so we need to start at 45. And then we end at a value above the maximum, so we'll end up at 100, and we will select a class width of 5, so 45, then 50, then 55, then 60, then 65, 70, 75, 80, 85, 90, 95, 100, and what we have done now is we created a bin range for Excel, in which we told Excel that we're going to start at 45, we're going all the way to 100, and in between we have 5 points all the time: 45, 50, 50, 55, 55, 60, and so on. And what does that mean? It means we have dictated the class width and we have dictated the span of the histogram. Keep in mind that Excel has a unique way of constructing a histogram, as we will find out later on that these values have a meaning that you can derive from the histogram. For right now, let us go to data again and go to data analysis, and this time we will select histogram because we are about to develop or create a frequency distribution. Then we click OK, and we're going to see the menu for a histogram, starting with the bin or the input range. Input range is the data. So again, we're going to start at grade in this column, and we'll go all the way down to the end of the column, which is inputting all the grade data. The second window is asking us about the bin range. So we're going to click on here and go to the bin range that we created a minute ago, and we insert this column into the second window. do we have labels? Now here is a very important thing. When you check labels, you want to make sure that you have labels on the grade column, on the variable column, and also a label on the bin range column. So label here means a label here, which is the grade, and the label here, which is the bin range. You cannot have just one label. That will confuse Excel. So when you click labels, you make sure you have a label here and the label there. Then we specify the cumulative percentage and the chart output, which are the ones that we are trying to develop. And then we go to output range, and we click on this window, and we find space in the spreadsheet. I normally use the cell next to the bin range that I have created so that I can verify whether Excel followed what I was asking or not. So now we're going to click OK after I picked the point where, or the cell where we want to display the output. We're going to say OK, and what we see here is a frequency table. Let me just enlarge it. Here is the bin range that we developed. So that was the one that we created earlier. This is the one that Excel is giving us, and as you can see here, it matches exactly the bin range that we created. Then Excel is giving us the frequency column, which is the number of observations belonging to each class or each cell. And if you go back to the lectures and go back to the previous session, you will know how we created these classes and the frequency corresponding to it. And then the final column will be the cumulative percent or the cumulative frequency. So bin range, frequency, then cumulative frequency. And as we can see here, we have the output, which is the graph of the histogram superimposed with the cumulative curve. Now, we could easily customize this graph. We can go in bin range and click twice, and instead of bin range, we can say grades. Okay, we can leave the frequency as is. We can also separate the histogram from the cumulative curve. In fact, I always recommend that to students so that they can actually analyze each graph independently and separately. So how we do that? We simply copy this entire graph down. So now we have two copies of it. We go to the top copy and we go and click on the cumulative curve. And as you can see, you click in all the points by clicking, just making one click on the curve. Then you click the right button of the mouse and say delete. And what you will see now is just the histogram. Okay? Same thing, you can go in the bottom graph, and this time you will click in the histogram and click on the right button and say delete, and what you will have is only the frequency curve. You can also simply delete this title here. So what we have here is the histogram alone and the cumulative curve alone. Now you can see that there are gaps in the histograms. That's a customization issue. You can click on the right button here and you can change the color of the histogram by clicking on the right button of the mouse, and you can say format data series, and you can change the fill color, for example, into yellow. You can also change the border color into black, and that will give us a different color. If you want to change or close the gaps, you can easily come here. It said gap width by clicking the right button of the mouse and just go all the way here, dictating no gap, and click close, and now you see a histogram very similar to the one that we created in the previous session. You can also change the font so you can see better, and here is a font of 16. And if you don't like the word more, because this is something that only comes with Excel, you can easily come here and delete it, and it will take away the word more, and you will have a simple histogram with the grade data on the horizontal axis and the frequency on the vertical axis. And you also have the cumulative curve, which you can customize as well. I will leave the customization to the students, but if you click on here, you can easily see that we have a menu of different plots that you can select one from. If I click here, for example, then I'm getting this kind of plot. If I click here, I'm going to get a different plot, and so on. So you select the plot that's suitable for you or you feel comfortable with, and then you can go here and change the labels. You can say grades, and you can go here and instead of axis title you say cumulative frequency, and you can actually change the font if you would like to, 14 or 15. In other words, there are a lot of customizations that you can do in Ecel that I will leave this up to you depending on how comfortable you are with what you see. The point here is that we just created a histogram and we just created a cumulative curve in a matter of seconds, and the key to know is we were in control of the class width. You can see here 45 to 50, 50 to 55, and we by producing these histograms we are now ready to obtain some information. At this point, I need to discuss with you that it's one thing to develop or construct a frequency distribution or a cumulative frequency curve, and it's another to obtain information from these plots. Descriptive statistics, as we were able to see in this session and the previous sessions, can be performed in a matter of seconds using Ecel or even more capable software programs that are numerous in the market today. So the analysis will be done for us. We have to select the type of analysis. In this case, we are selecting descriptive statistics, numerical and graphical. And as I said before, descriptive statistics is a must-do type of analysis anytime you do statistical applications. Even if your goal is to do other analysis, you need to start with descriptive statistics first, because it simply gives you a good description of the data that you are dealing with, and it also helps you detecting any outliers or any abnormality in the data before you move on and do more advanced analysis. But the other issue is to realize what we are producing here. We're producing graphs, we're producing descriptive statistics, so we should be able to describe these statistics, and we should be able to make our own interpretation. That takes us to the issue of information obtained from descriptive statistics, which I'm about to address via the slides we have. Let's go to the slides. Information obtained from descriptive statistics. It's very important before we try to describe data or look or analyze the output of descriptive statistics is to categorize data into three types. The first type is nominal, the best. The second type is larger, the better. The third type is smaller, the better. This categorization will help us a great deal in interpreting the outputs of the descriptive statistics. A nominal, the best variable is a variable that should have values that are not too high and not too low, just exact. For example, if we are talking about tiles, ceramic tiles or any other types of tiles, when we buy or purchase tiles, we expect them to have a well-defined dimensions, not above and not below, the exact dimensions. When we buy pipes or when we use pipes in any plumbing task, we also expect these pipes to come in a specific diameters, specific dimensions that are not too high and not too low, just exact. When we use papers or envelopes, we also expect these to be of pre-specified size, not too high and not too low. These are variables that follow the nominal, the best category. Other variables will follow the larger the better category. And there are many variables that follow this category. For example, your grades, you would like it to be as large as possible. You want the highest grades in the class. So a low grades is not desirable, and higher grades are desirable by all students. And what does that mean? It means it is a larger the better variable. Income and debt. See, if we look at income, all of us would like to have the highest income we can possibly have, and that is a larger the better variable, in contrast with debt, for example, which is smaller the better. Health performance parameters. There are so many health performance parameters that follow larger the better. Then smaller the better. As I said earlier, income is larger the better, debts are smaller the better, birth defects would like to have the smallest birth defects rate possible, so that's another smaller the better variable. Manufacturing defects, returns, rejects, all of these are smaller the better variables. So it's very important to have a good idea about what category of variable we are describing before we look at descriptive statistics. Now, going back to students' grades. When we look at students' grades from descriptive statistics viewpoint, we can easily look, first we have to think of students' grades as larger the better, as we discussed a minute ago. And as we look at the mean value, we can see 76.3. We can see a median of 80, a mode of 80, and what that tells us in line of information is that the average value of this class is a high C. But the mode, which is the majority of the grades in the class, is 80, so that's a B. The median as well. As we look at the minimum and the maximum, we see that this class has students that have failed the class with a minimum 48, as you can see here, and also has superior students who were able to make 98. That's a very high B, very high A. So that gives us a good idea about the center of the grades, the mode. It gives us a good idea about the minimum and the maximum. It gives us a good idea about the range. We have a 50 points range from the lowest grade to the highest grade. And later on, we will discuss with you how to use the values of the standard deviation and the variance in further describing the data. What the descriptive statistics in numerical sense does not tell us is what percent of students, for example, have failed the class, or what percent of students have made an A or made a B in the class. And that's where we need the graphical representation. We need this table here. We need the frequency table, and we need the histogram and the cumulative curve. So when we have the histogram, we actually completing the information that we need to obtain from a set of data. We can look at this histogram, and as you can see, all the grades are displayed in categories or classes, and we have bars representing the frequency corresponding to each class. And we can look at this histogram and roughly tell how many students have failed the class, because they are represented by these red bars here, and how many students that have made an A in the class, and they are represented by these green bars here, and how the majority of the class did, which is the middle portion of the histogram. So a histogram will widen our view and provide us with more information and better resolution of the variable that we are trying to analyze. So we can also get the percentage of the students that have made failed the class, and the percentage that have made an A in the class, as well as the percentage of the bulk from a C to a B students. These are percentage that can be obtained by simply adding up these graphs, these heights, these bars, and when we add the heights of the bars, we are very much looking at the number of students, and we can divide that by the total number of grades or the total number of students and get the percentage. As you can see here, 10 divided by 40 times 100 will give us the 25%. What is the 10? 10 really is the add up of the heights of these bars. Here we have bars that add up in heights to 9. 9 divided by 40 divided times 100 will give us the percent of students that have made 90 or better. And so on. We can also get these values from the frequency tables by looking at the frequency up to some threshold values and add up these numbers and divide it by the total frequency times 100 and get the exact or the close to exact percent frequency of some categories that we are interested in. The cumulative curve, as we mentioned earlier, gave us the percent of values that are less than or equal some threshold value. So this is very important. If you want the percent of values of grades that are less than or equal some pre-specified value, let's say less than or equal 70, you can go straight to the cumulative curve at 70 and you go up, intersect with the curve, then go horizontally, and that will give us the exact percent of grades that are less than or 70. We have 30% of the grades or 30% of the students that have made 70 or less, or C or less, or low C. We can also look at other values. We can look at students that have made less than or equal 90. And that is obtained directly by going at the 90 up until you intercept with the curve, then draw a horizontal line, which will give you the value directly on the vertical axis, as you can see. And if you know the less than or equal 90, you can easily calculate the greater than 90 because, as you know, the total cumulative frequency is 100. So 100 minus 92.5 will give you the 7.5. These are information that we obtain from the cumulative curve. We can also get the value in the middle, the percent of values from 70 to 90, by simply subtracting the percent here less than or equal 90 from the percent here less than 70. By subtracting these two, that will give us the percent of values from 70 to 90 grades. If we move on to the ceramic tile example, this is the nominal the best category, meaning we need exact values. So here we have some values that we collected from a sample of ceramic tiles, and following the procedures we discussed in this session and the previous session, we can calculate the descriptive statistics, and we can also construct frequency distribution and cumulative frequency curves. And what we see here is the mean value, the median, and the mode. And you can see that the mean and the median and the mode are very much the same, which, as we will discuss later on, it simply indicates a very symmetrical distribution or frequency distributions of ceramic tile areas. We can also look at the range of 6.8 with minimum 252.7, maximum 259.5. You would think that ceramic tiles should have identical areas, but variability will always prevail because no matter what we do in manufacturing, we're always going to have variability. So we have a minimum of 252.7, maximum of 259.5 by this analysis, and observing these values give us a good idea about the variable being the area of the ceramic tile, the center values, as well as the dispersion or the variability values. We can then go to Ecel, as we mentioned before, and we create a bin range. Notice that this bin range is created based on the information we got from the descriptive statistics table. We have a minimum of 252.7, a maximum of 259.5. We select a value that's below the minimum. Here we have 252, and go all the way to a value that's above the maximum. Here is 260, and then we select the class width. And since this is ceramic tiles, and since we do not expect high variation between tiles, we would like to think of 0.5 as being the class width. So what we have here is 252, 252.5, 253, 253.5, and so on. So our class width, or the distance between values in the bin range, are only 0.5 inch. And then we can go to data analysis, select histogram, as you can see here, and we after we select the histogram, we can select the input range, being the entire column of the tile area. As I said earlier, we have to arrange all the data of the variable in one column, and we input this data, including the label, and that's the input range. Then we go to the next window and input the bin range, and then we select the cumulative percentage and the chart type, and we specify an output, and we click OK. And when we do that, we will get the outputs that we've seen a few minutes ago, which are the cumulative frequency curve and the histogram. Now we need to stop here and think a little bit. This example is a ceramic tile example. And in the real world, when people buy ceramic tiles, they are expecting to have well-specified values. If we go to the slides now, we'll see that there is an example that in which we have specifications. Suppose that in the tile area example, a consumer would like to purchase tiles of the following specifications. He wants a target of 256. So we got lucky here because our average value based on the sample we just looked at is 256. But he will not tolerate anything that is below 255 or above 257. So he's given us specifications of 256 plus or minus 1. Okay? As a manufacturer, you should determine what percent of your tiles that can actually meet these specifications. And the way we do that, we can go to the histogram and roughly look at our histograms by locating the specifications. We have 255 as the lowest specifications. We have 257 as the highest specifications. And looking at this graph here gives us a good idea about where or what percent of our distribution that will satisfy the customer specifications and what percent will be rejected. Now the values here will be roughly calculated, because as you can see, the 255 happen to be in the middle of this bar, and the 257 also happen to be in the middle of this bar. So you will not be able to get an exact value, but you can easily look at this portion here and this portion here and kind of get a good estimate, rough estimate of what percent of your ceramic tiles that will be rejected. If you move to the cumulative curve, you will be able to obtain more accurate information, simply because we have a specification from 255 to 257. So if you go at the 255 and draw a line, and go at the 257 and draw a line, that's a vertical line, then we will have the specified area. And from the cumulative curve, we can easily get the percent by looking first at the 255 to specify the rejected area, go up, intercept to the curve, then go horizontally, and that will give us the percent of values that are less than or equal to 55. And you can see we have here 25%. We can go to the other side of the specification, the 257, and in order to calculate this area here, we can easily go of what the cumulative curve will give us, which is x less than or equal to 57, which is this entire area, which is 85% of the area directly obtained from the curve, and 100 minus 85 will give us this rejected area here, that would be 15%. So we now have the percent rejected in the upper side and the percent rejected in the lower side, because this is a variable that follows nominal the best category, so it will have to be right in the middle. And from these two values, if we subtract 25 from 85, we can get the percent of ceramic tiles that will actually meet the specifications of 255 to 257, and that will be a 60%, and that's a very important piece of information, which means we have to go back now to the customer and tell the customer that the best we can do for you to meet your specifications is 60% of what we produce, and beyond that you may find 15% on the upper side and about 25% on the lower side. Indeed, if you are a manufacturer, you need to take some actions to correct this problem. And where you start with where the problem is actually big, and that is the lower side, because you have a percent of the lower side of 25%, so you need to see why your ceramic tiles are not meeting the target average of 256, but rather below 255, and do something about it. Then you can move to the upper side, it's a 15%, and see why some of your ceramic tiles are larger than the specification values. That is how we obtain important information. A part of obtaining information from cumulative curves or frequency distributions is also to be observing or to observe the different shapes of the frequency distribution. This is a symmetrical shape, which later on we will describe it as a normal distribution, where we have a symmetrical distribution, as you can see here, with the mean and the median and the mode being the same. Indeed, when you have a symmetrical distribution, then you have a mean, median, and mode that are identical. But that's an ideal distribution. In the real world, you may get a distribution that will be biased to the skewed to the right, or the heavy frequency is to the left, which means that the mean and the median and the mode will not be coincided, as in the first case. Or you may get a distribution that's skewed to the left, in which, as you can see here, it's a different scenario. And of course, as you look at these distributions, you may think of the three categories we mentioned. We would like the nominal, the best, which is the exact value, to follow this symmetrical distribution, while we would like to see students' grades to follow this distribution, since the heavy frequency or the bulk of the distribution at the higher values or the higher grades, while we would like to see returns or rejects following this distribution, since, as you can see here, the highest frequency is at the lowest values. So we can read a lot from the shapes of the distributions. Other shapes may look something like that, steep shape, where the distribution is trying to be entirely located at the center. We may also see a flat shape. We may also see a bimodal or multiple modal shape. Anytime you have a mix of data, you may get a frequency distribution that would look something like that. In other words, we need to be able to describe the frequency distribution, and in order to do that, we have to understand the underlying concepts, as well as the method used to construct a histogram. So again, in order to obtain information from a histogram or a frequency distribution, the first thing that we have to have is a good knowledge of how we constructed the histogram and the cumulative curve. Indeed, quite often we are deceived by histograms that we see in the news or reported by some organizations, and we are deceived because we don't understand the underlying concept of a histogram or how a histogram is constructed. We need to know how to construct a histogram. We need to know the key parameter of a histogram, which is the class width. And when we compare between two histograms, we want to make sure that these two histograms are constructed identically. If you're looking at people income last year and people income this year via histograms, then these two histograms should be constructed identically, so we can actually compare between the two. Otherwise, the comparison will be invalid. We also need to think of the variable, whether it is nominal the best, larger the better, smaller the better, because understanding the nature of the variable and the desired values of the variable will help us a great deal in interpreting the outputs and obtaining even more information from descriptive statistics. At this point, we will stop, and the next session will be about analytical aspects associated with the statistical distributions. Until then, I'll see you. Thank you.